In this video, we're going to look at rearranging equations and formulae. If you can solve an equation, you can rearrange an equation. The issue some students have is that when they solve an equation, their answer, for example, x, is equal to a number. When we're rearranging equations, we might have x is equal to y plus z divided by 2. So rearranging an equation doesn't give us a nice pretty answer in terms of a number, it just gives us x in terms of other letters. We use exactly the same technique as we would to solve an equation as we're going to for rearranging equations. What we'll do is start off with some basic equations. So in this question we're asked to solve the following equations for x. What you'll see is that these get slightly more challenging as we go. If you get lost at this stage, that's perfectly fine. Some of these down here are slightly more challenging. What we'll do in the video is work through lots of different examples and look at techniques that we can use to solve them, and they will start very straightforward. So this is a nice, easy equation. So if you're not comfortable with solving that equation, I think it's best if you do a bit of revision on solving equations first, as it just requires some basic skills. This is slightly more challenging, this one too. Then when we have unknowns on both sides, again slightly more challenging. And then finally these two right here, they don't need a massive amount of skill, but it's perfectly fine if you haven't studied maths to this level yet. So whilst I'm doing these, if you do get lost, don't worry. The first examples we're going to do of rearranging equations will be all these type of problems. It will be 1 and 2 step rearranging. So let's look at the first one. What we've got is 2x minus 1 is equal to 5. There are lots of different ways you can think about solving this. If you're not comfortable with algebra, often you can simply work this backwards. So what we have is 2x minus 1 is equal to 5. All we would do to use a very basic method of working backwards is undo this equation or do the inverse operations. So what we'd do is add 1 and divide by 2, because that's the opposite. We got minus 1 and multiplied by 2. So we'd add 1 and divide by 2. So we could say that 2x is equal to 6 and x is equal to 6 divided by 2, which gives us 3. So that's just working backwards, nothing too crazy about that. That technique is perfectly fine. If it's easier to use that technique, go ahead and do it. The more challenging examples, though, may require you to think about a deeper way of solving an equation, and that is to see it now as the equation balances, and what you do to one side, you must do to the other. So if I looked at this equation again, 2x minus 1 is equal to 5, what I would do is just add 1 to both sides. So I'll write this add 1 to both sides. You certainly don't need to do that in your working, but it just shows what I'm doing. So 2x will be equal to 6, and then we would divide both sides now by 2, and that would give me that x is equal to 3. So you might say, well, you've done nothing different. Absolutely. But trying to work backwards, for example, with an equation like this is going to be slightly challenging. Okay, with this one, what we've got is 2x minus 1 divided by 3 is equal to 5. So if you wanted to work it backwards, we'd multiply by 3 instead of dividing by 3. We would add 1 instead of subtracting 1, and we would divide by 2 instead of multiplying by 2. So 2x minus 1 is equal to 3 times by 5, which is 15. Then we'd have now 2x is equal to 16, and then x is equal to 8. You might use the technique of change sides, change signs. Again, it's entirely up to you. If I were to solve this with a more sort of, I don't want to use the word rigorous, a more sort of traditional method, then we would say multiply both sides by 3. We're just undoing this by simply doing the same to both sides. So 2x minus 1 is equal to 15. We would add 1 to both sides. So that would give us now 2x is equal to 16. And then we divide both sides by 2. And that would give us now that x is equal to 8. What I'm trying to do in each of these situations is isolate x on its own. Now it doesn't matter whether that's on the left hand side or the right hand side. What we're trying to do here is get x by itself. Once I've got x by itself, I can say that x is the subject of this equation because x is equal to 8. If I don't have x on its own, then that isn't the subject of the equation as such. And you might think, well, why is this important? Well, when we look to rearrange an equation, what we're trying to do is isolate, so get by itself, the unknown or variable, such as x, and write x is equal to, for example, 2y plus z. So this technique just goes straight across, but as stated earlier, you're not going to have numbers, you're going to have letters and possibly numbers. Right, this one here, I'm going to do this two different ways. If you wanted, what you could do, instead of expanding the brackets here, you could simply divide both sides of this equation by 5. If we did that, what I'd have now is 2x minus 1 is equal now to 3. Then I'd simply add the 1, so 2x is equal to 4, and then x is equal to 2. So I've saved myself a bit of work. If you wanted, you could expand that out, and then we'd have 10x, we multiply everything on the outside by the inside, minus 5 is equal to 15. Then we would add the 5 to both sides, so 10x would be equal to 20, and then we'd divide both sides by 10, so x is equal to 2. So same answer. When it comes to rearranging equations, often dividing through by a common factor is a lot easier. Sometimes, though, expanding can give us a nicer answer in terms of the final way it can be written. And what we'll do is look at different ways that we can write an equation and have something as the subject. Because, for example, now we could have just divided here, and it would have given us a different look to the equation. And certainly when you're dealing with other letters, it's going to look different in the answer, as we'll see. So if you're only comfortable up to that point, that's perfectly fine. These are the techniques that you're going to use to rearrange basic equations. What I'm going to do here, though, is just move on and look at solving some of these. So if you want a 5-minute break and say, that's about my limit, that's perfectly fine. With this one here, we've got two choices. I could divide both sides of the equation by 5. What I do to one side, I've got to do to the other, as this is a sign of equality, equals. If I divided both sides by 5, on the left I'd have 2x minus 1 is equal to 2 bracket 3x plus 1. So now at this stage I would simply go ahead and expand the right hand side out. So 2x minus 1 is equal to 6x plus 2. I would subtract 2x from both sides, so negative 1 would be equal to 4x plus 2. I would now subtract 2 from both sides, so negative 3 is equal to 4x, and I divide both sides by 4, so negative 3/4 is equal to x. If you didn't like that and you didn't spot that, then you could just expand the brackets out. So if we expand the brackets out on the left hand side, we will have 10x minus 5, and expanding the brackets out on the right hand side, we'd have 30x plus 10. If I subtract 10x from both sides, I've got 20x plus 10. And then if I subtract 10 from both sides, I've got negative 15 is equal to 20x. And then dividing both sides by 20, negative 15 over 20 is equal to x. And we can see that's an equivalent fraction. Negative 3/4, negative 15 over 20. We'd simply divide both of these, top and bottom, numerator and denominator, by 3. So there we go. What you've seen in that technique, yet again, is me trying to isolate x, getting x on one side, such that we only have x's on one side, and we only have anything without an x on the other side, which in this case is just numbers. Right, let's look at this one. So this one right here, we've got 2x squared minus 1 is equal to 17. So if you want to think how x started its life off, x was then squared, got multiplied by 2, it had 1 subtracted, and it gave us 17. So if we work that backwards, we're going to add 1, we're going to divide by 2, and we're going to square root our answer. So 2x squared is equal to 18 by adding 1 to both sides. X squared is equal to 9, dividing both sides by 2. And x is going to be equal to plus or minus the square root. The inverse of squaring is square rooting. And if we have now a squared term, or if this power here is even, we're going to have a plus or minus answer. 3 times 3 is 9, but also negative 3 times negative 3 is 9. So our answer for x here could be x is equal to plus or minus the square root of 9, which is 3. If you have an odd power, you're just going to have one answer. So if you took the cube root, for example, of, let's say, 8, our answer would be 2. It wouldn't be plus or minus 2. Because if we cube negative 2, we get negative 8. So it gives us a different value. So that's that one. Just again, just solving a basic equation. This one right here, so 2x minus 1 all cubed, so 2x minus 1 all cubed is equal to 27. So yet again, I'm just trying to get x by itself. So what I've got to do is work backwards, or if you like, undo the operations using the inverse to get there. So with this one, x got multiplied by 2, it had 1 subtracted, that was all cubed, and that gave us 27. So the first thing we need to do is take the cube root of both sides. The cube root is the inverse of cubing. Cube root of 27 is going to give me 3, and then this is nice and straightforward to solve from here. Adding 1 to both sides, and then dividing both sides now by 2, and x is equal to 2. And if you just check that, if we substitute x is 2, 2 times 2 is 4, minus 1 is 3, 3 to the power 3 is 27. So there we go. So what we've seen is a couple of different techniques to solve equations, and all we're going to do now is put that into action with rearrangement. So I appreciate that we've been going nearly 12 minutes, but hopefully that'll give you an idea of what to do. So in this question it says make x the subject of the following equations. At the moment here, y is the subject. What we want is x. Here we've got y as the subject, y as the subject, because y is expressed in terms of other unknowns or variables. Y is equal to x divided by z. If we want x as a subject, we need x is equal to something, not 2x is equal to something or x squared. We just need x is equal to something. So on the first one, this is nice and straightforward. What we have is y is equal to 2x. We just want x. So all I'm going to do is divide both sides of this equation by 2, and we can say y divided by 2 is equal to x. X is now the subject. It doesn't matter that it's on the right-hand side rather than the left-hand side. We could write x is y over 2, or y over 2 is x. X is the subject of that equation, as we've isolated the x. If we look at the next one, we've got x divided by z is equal to y. So if we just want x by itself isolated, we need to do the inverse. At the moment, it's divided by z, so we need to multiply both sides of the equation by z. And that will give me x is equal to y times by z, or z times by y, and I'm going to write that as yz. You might think, well, it's zy. Perfectly fine. Zy is yz. I just prefer to write it alphabetically. If you think 2 times 3 is equal to 6, 3 times by 2 is also equal to 6, so we can write that any way round. Now the next one is y divided by x is equal to z. So y divided by x is equal to z. So here it looks like we've got a lot of work to do. But let's just write up here. If I have 12 divided by 6, this gives me 2. What I also know is that 12 divided by 2 gives me 6. So if I want x to be the subject, I can do this as a one-step move. I can do it in 2 steps, but I can actually do it in 1. All I need to do is simply swap the z and the x over. We've seen with a numeric example that 12 divided by 6 is 2 and 12 divided by 2 is 6. So what we'd have is y divided by z is equal to x. Now x is isolated, x is the subject. If you weren't comfortable with that, you could have done it in 2 steps. You could have said x times by z is y, and then divided now by z. So if you want to do it in 2 steps, you can. This one just here, we've got x divided by z is equal to z. No issues with this. If x is divided by z, to isolate it, to get it by itself, we simply do the inverse, the opposite to dividing by z, which is multiplying both sides of the equation by z. So this will give us z times by z, which is just z squared. Just think about it. If x divided by 4 was equal to 4, then x is going to be equal to 4 times by 4, which is 16. So 16 divided by 4 is 4, 4 times 4 is 16. We can see it works nicely. This one right here, x divided by 3 minus 1 is equal to y. If I told you now that y was a simple number such as 2, you'd be perfectly fine with this because you would add the 1 and multiply by 3. Students kind of get a bit scared at this point because they don't know what y is. Well, we don't need to know what y is. We're simply making x the subject. So we'll have x is equal to something. So what we'll first do is add the 1 to both sides. So it'll be y plus 1 or 1 plus y. 2 plus 3 is the same as 3 plus 2. These are what we call commutative. You can move them around. And then at this stage, if x divided by 3 is going to be equal to y plus 1, we simply need to multiply both sides by 3. When I do that, I'm going to get 3 lots of y plus 1. Don't write that it's 3y plus 1. It's 3 multiplied by all of that quantity, y plus 1. So again, don't be scared about these things. It literally is just solving straightforward equations. Let's look at the next one. 1 minus x over 3 is equal to y. A few different approaches with this one. This is slightly more challenging. Here is one way that we could do this, and this is to make x positive. It's easier to work with positives than it is negatives, especially if you're not comfortable with multiplying and dividing by negative numbers. So what I'm going to do here is write that this is going to be 1 is equal to x plus 3 by adding this quantity to both sides plus y. So by doing that, I've automatically now made x over 3 positive instead of negative. I'm now going to subtract y because what I want is on the right hand side, I just want things with x in it. On the left hand side, I want everything without an x. That's all we've ever been trying to do. We've been trying to get x on one side and everything without an x on the other side. So this is going to be 1 minus y is equal to x divided by 3. So all I need to do to finish this off is the opposite to division by 3, which is multiplying by 3. Or you can say that we can divide both sides of this equation by 1/3. Entirely up to you. I'm just going to multiply across, so it'll be 3 lots of the quantity 1 minus y. It's not 3 times 1 and then just y, it's 3 lots of all of this, and that's why we bracket off. And now x is isolated, x is the subject. If you didn't want to do this, here is another way, and again, depending on your confidence, what we could do is simply subtract 1 from both sides. So here, instead of adding this quantity, I'm left with this. You can do this in 1 or 2 ways. The nicest way to do it is to say I'm going to divide both sides of the equation by negative 1/3 or multiply both sides of the equation by negative 3. If you did that and multiply both sides of the equation by negative 3, this is what you would have. Because essentially what we're doing here is if we multiply this, if you multiply all of this by negative 3, the 3's will cancel and 2 negatives will make that positive. Again, more mathematically rich would be to say divide by negative 1/3. If you're looking at that answer and thinking, hang on a moment, it doesn't look like what we've got down here, the only reason is because we've got negative 3 outside instead of 3. If you wanted to expand the brackets here, you get minus 3y or negative 3y plus 3, which would give us 3 minus 3y, which we could write as 3 1 minus y, taking the common factor of 3 out. So again, don't be majorly concerned about that. It's just a different way of looking at it. Right, okay. Now, let's move on. Here comes the interesting part, and this is where we have brackets. And the question is, do we expand them or do we not? My belief is it's up to you. It will always look tidier, well, generally speaking, if you expand the brackets, but you don't have to. And what we'll do is give you 2 different options. See, what I'm trying to do with question H, and I'll write it just here, we've got 2 bracket x minus 1 is equal to y. And we're always, on these particular questions, we're making x the subject. My head says x started off, it had 1 subtracted, and all of that was multiplied by 2. So if we work that backwards, we're going to divide by 2 and add 1. So if I did that, what we'd have is x minus 1 is equal to y divided by 2, and then x is equal to y divided by 2 plus 1. And that gives us x in terms of y, and then a constant, or just a number. Okay, could we have done that differently? Yes, we could have done, and we could have written this now as 2x minus 2 by expanding the brackets is equal to y. 2x is equal to y plus 2, and then x is equal to y plus 2 divided by 2. And that in itself looks, I think it looks a little neat, and you're thinking, well, why is this a 1 and why is this a 2? Well, if you consider 1 as an equivalent fraction over 2, 1 is 2 over 2, so you can combine those fractions and simply write y plus 2 over 2. Right, the next one, again, you can expand the brackets or you can leave it as it is. It's no different, this one, really, but the difference here in terms of our final answer, I will show you both ways. So what we'll do is 2 bracket 3x minus 1 is equal to y. If I divide this by 2, both sides, that's what we'll have. Remember, my goal is to always isolate the term in x. I'm just trying to get x by itself. I don't want x plus 1, I don't want 3x, I just want x, and I certainly don't want y on the same side as x. Here goes. 3x is equal to y plus 2, y divided by 2 plus the 1. And here's where it gets messy in terms of our final answer, because we need to divide both sides by 3. So this becomes y divided by 2 plus 1 divided by 3. I kind of like that, but mathematically it could look a lot neater. But again, it's a perfectly fine way to write it. It's not wrong. It's certainly not wrong. But here, if we wanted to make this nicer, if I multiply the top and the bottom of this fraction by 2 to clear this denominator here, we could say that this is going to be y plus 2 divided by 6. And that's just to tidy this up. Now, if we had gone the other way and said 2 bracket 3x minus 1 is equal to y and expanded the brackets, we would have had 6x minus 2 is equal to y. We would have had 6x is equal to y plus 2, and then x is equal to y plus 2 divided by 6, so you can see it's exactly the same. But by multiplying out the brackets, we end up with a slightly tidier answer. So in terms of the way it's written, you're not, unless you're told to show that x can be written as y plus 2 over 6, this is perfectly fine. And certainly if you're going to multiply through the bracket and the answer isn't going to be very pretty, well, my gut instinct says that you can go ahead and simply divide through to begin with. Right, let's have a look at this one here. Not an awful lot different. So with this one again, you can divide both sides by 2 or you can expand the bracket out. I'm going to go ahead and expand the bracket out because I think the final answer is going to look a little tidier. 2 bracket 3x minus 1 is equal to y plus 1. So 6x expanding the bracket minus 2 is equal to y plus 1. We want x by itself, so I'm going to add 2 to both sides. So that'll give me y plus 3. And then x is equal to y plus 3 divided by 6. Again, if you divided through, you would have had 3x minus 1 is equal to y plus 1 divided by 2. 3x minus 1 is equal to y plus 1 divided by 2 plus 1. And let's just get rid of that. We've already done that. Let's get rid of that. There we go. And then we would divide all of that by 3. And if your ability to tidy up the fractions is okay from that point, again, multiplying through by 2 is going to give you exactly the same answer as this. So that's that pretty much of a muchness. This one here, y minus 3, so y minus 3 is equal to 2 bracket 3x minus 1. Could divide by 2, I'm going to expand the bracket. Y minus 3 is equal to 6x minus 2. adding 2 to both sides, y minus 1 is equal to 6x, and then y minus 1 divided by 6 is equal to x. I'm just solving an equation for x, no different to one of the ones we did on the first page 20 odd minutes ago. And hopefully at this point we shouldn't be too concerned. Right, let's do something slightly more challenging. These ones here, y minus 1 divided by x is equal to 5. So what we need to do here is isolate x, get x by itself, express x in terms of y and some numbers. We looked before at the idea that 12 divided by 6 is equal to 2, and we know that 12 divided by 2 is equal to 6. So if I have y minus 1 divided by x is equal to 5, I can simply swap these over. So y minus 1 divided by 5 is equal to x. Again, if you want to multiply both sides by x and then divide both sides by 5, you're more than welcome to do it. But within one move, I've made x the subject of that equation. Right, next one, we've got y minus 1 divided by x plus 1 is equal to 5. Again, I can swap those quantities around. Don't just swap the x. Remember, this is x plus 1. We need to take this as the whole quantity x plus 1. So y minus 1 divided by 5 is equal to x plus 1. I want x by itself, so I simply need to subtract 1 from both sides. Y minus 1 divided by 5 minus 1 is equal to x, and now x is the subject. Okay, y minus 1 is equal to, if we hadn't just swapped these over, we would have had 5 times by x plus 1, by multiplying both sides of the equation by this quantity in an attempt to isolate x. Expanding the brackets, we would have had 5x plus 5. We want x by itself, so subtracting 5 from both sides, y minus 6 is equal to 5x. Dividing both sides by 5, y minus 6 over 5 is equal to x. Again, different, it looks different, doesn't matter, because if you wrote this as an equivalent fraction, 1 is 5 over 5. And that's why we have now y minus 6 over 5, because if we have 5 over 5, we can simply combine that as a single fraction. Right, have we got any? Yeah, we've got some more space. So, next one, we've got y squared minus 1 over x plus 1 is equal to 5. So, y squared minus 1 over 5 is equal to x plus 1. And y squared minus 1 over 5 minus 1 is equal to x. Do not be concerned with this y squared. It has no bearing on what we do in terms of the process. Instead of y, it's just y squared. Really doesn't matter. We're not making y the subject, we're making x the subject. If we look at this one though, y minus 1 over x squared plus 1 is equal to 5. Then we can say y minus 1 over 5 is equal to x squared plus 1. So we still have 2 steps to go, because we don't want x squared, we want x in terms of y and these numbers, or the constants. So I'm going to subtract 1 from both sides, so y minus 1 over 5 minus 1 is equal to x squared. We now need to do the inverse of squaring, which is square rooting, and as we saw before, we get a plus or minus answer, and it's plus or minus y, square root of y minus 1 over 5 minus 1, all under the square root, is equal to x. Again, you could have made that look a little prettier by multiplying through by here, expanding the brackets and refactoring, but that's perfectly fine as an answer. There's no issues at all. As you can see, nothing really changes. So there we go. Now let's move on and look at something I would say slightly more interesting and slightly more relevant. It says the equation v is equal to u plus at is used to find the velocity of an object. Currently v is the subject of the equation. So what we've got is v isolated, and it's expressed in terms of u, a and t. This says v, which is the final velocity, is equal to u plus a multiplied by t. Don't worry about at. Remember, if we don't have a sign between two numbers, it means multiply. Or if you have a number and then brackets, it just means multiply. What we're being asked to do here is start by making u the subject. If we think about this reasonably, v is equal to u plus at. All we're trying to do is isolate u. So we want u on one side and anything that doesn't have a u on the other. So all we need to do is the opposite to add in, and that's simply subtracting. So it's v minus at is equal to u. And now I've made u the subject. We're now asked to make a the subject. Only one more step. So that is v minus at is equal to u. So let's make a the subject. V is equal to u plus a multiplied by t. So if you wanted to undo this, you can work backwards. It's a nice straightforward example. So all we would do is v minus u is equal to a multiplied by t. At this stage, we can go ahead and divide both sides of this equation by t. It's just saying a times t is v minus u. So v minus u divided by t will give us a. We now need to make t the subject, well, no different to what we've just done, but instead of dividing by t, we divide both sides of the equation by a. So v is equal to u plus a t. V minus u is equal to a t. And then v minus u divided by a is equal to t. T is now the subject. V is the subject. We've got now a is the subject, or u is the subject here. We've got a is the subject here, and we've got t is the subject here. So what we can do is move these around such that we can express one quantity in terms of the other. Okay, let's look at some more. So we've done question 3, there we go. So in question 4, we need to make p the subject of the following equations. So what we've got on the first one is q minus 3 is equal to p squared. At the moment, p squared is the subject. So all we need to do is the inverse of squaring, which is square rooting. So we need to do that to both sides. So as we saw before, we're going to get plus or minus the square root of q minus 3 is equal to p. And that is nice and easy. P is the subject, p has been isolated, doesn't matter whether it's on the right or the left. If we look at q minus 3 is equal to p cubed, again, p is not the subject, p cubed is. To make p the subject, we need to do the inverse. The inverse of cubing is cube rooting, and we can write that as the cube root of the quantity q minus 3 is equal to p. We don't get a plus or minus, as this now is an odd power. Even powers will give us a plus or minus, odd powers won't. The next one, q minus 3 is equal to the square root of p. The opposite to square rooting is squaring, so we square the quantity q minus 3, and that will give us p. We have to be careful, don't write q squared minus 3 squared, it's q minus 3 squared. They are completely different. With this one here, what we have is q minus 3 is equal to 2/5 of p cubed. We can do this in one step to get p cubed by itself, or 2 steps. The easiest way is to first multiply both sides by 5, which will give 5 is equal to q minus 3, 5 lots of q minus 3, and that will be 2p cubed. Then we can divide both sides by 2, so it's 5 over 2 q minus 3 is going to be equal to p cubed. And then we can take the cube root. So the cube root of 5 over 2 q minus 3 is equal to p. What you could have said though, we could have just simply divided both sides of this equation by 2/5. Dividing by 2/5 is the same as multiplying both sides by 5 over 2. When you divide by a fraction, you multiply by its reciprocal. So if you're comfortable, you can go straight to this step by writing that. You could have even written 5 lots of this over 2. It really doesn't matter. Right, this one just here. We've got now 2 bracket p plus 3 is equal to q. Do we need to expand that? Entirely up to you. What we need to do though is isolate this term here, this p term. So you could multiply the brackets out, or you could simply divide both sides of the equation by the 2. and then subtract the q. So p would be equal to 3 over 2, or 1.5, minus q. What I would suggest is that if you're working with fractions, leave them as fractions. Don't be tempted to write them as decimal answers. It doesn't leave it often as an exact value. So for example, if you tried to write 2/3 as a decimal, 0.6 recurring, things get messy. Exact fractions are easier to work with, especially if you don't have a calculator. So that's nice and logical. The next one is going to give exactly the same answer, but we're just going to have a change of sign. So on this one, what we've got is 2 bracket p minus q is equal to 3. So divide both sides by the 2, and this time you're going to add the q instead of subtracting it. If you wanted, you could expand this. 2p minus 2q is equal to 3. 2p is equal to 3 plus 2q, or 2q plus 3, by adding that to both sides. And then we would have on here that p is going to be equal to, let's just put this in, 2q plus 3 divided by 2. So it's, again, entirely up to you on how you want to do that. Where are we now? This one here, right, let's just go on a page so we've got a bit more space. So this one is on 2 bracket q minus p is equal to 3. I would personally say, well, q minus p is equal to 3 over 2 by dividing both sides of the equation by 2. At this stage, we can say that q will be equal to p plus 3 over 2 by adding the p to both sides, and then q minus 3 over 2 is equal to p, and p is expressed in terms of q. You didn't have to. Now, you could have expanded it out, or what you could have done at this stage, you could have said, well, if q minus p is equal to 3 over 2, subtracting q from both sides will leave us negative p is equal to 3 over 2 minus the q. Then dividing both sides of the equation by -1, that would give us negative 3 over 2 plus q, and that is exactly what we've got here, just written the other way round. So if we're going to divide both sides by -1, or multiply both sides by -1, we end up with changing the signs of those values. So that's that one. This one just here, no different really. You might, let's just do it, 2q minus p, and that's divided by 5 is equal to 3. So at this stage we can multiply by 5, divide by 2, or you can simply divide both sides by 2/5. Dividing both sides by 2/5 is the same as multiplying by 5 over 2. So what we'll do it like so. So 2 lots of q minus p is equal to 15. So we've got q minus p is equal to 15 over 2, and then q minus, in fact we'll do it as q is equal to p plus 15 over 2. So q minus 15 over 2 is equal to p. So many different approaches with that, it's untrue. The reason I divided both sides by 2 is because we just had a number on the right hand side, and I think it's a lot easier, it just looks a lot neater to do. Right, let's go ahead and do this one. So what we've got here is 2 and then bracket p plus q. So we've got p stuck in these brackets, so we're going to have to get that out and isolate that, and that's equal to q minus 1. Right, because I've got q's here and I've got q's here, I've got q's on both sides, what I'm going to do is expand the bracket. It will just make it look a bit tidier. 2p plus 2q is equal to 5q minus 1. I only want p's over here, don't want q's, want to isolate the p, not the q, don't want q over here. So let's now subtract 2q from both sides. So 2p is equal to 5q minus 2q, which is 3q minus 1. Divide both sides by 2, 3q minus 1 over 2, and that's nice and clean. You could have divided both sides by 2 at this point, and then you would have subtracted q from both sides, and it just wouldn't have looked as nice. This one just here, well, let's go ahead with exactly the same technique. All we're going to do is get up to this stage right here, but instead have p squared is equal to 3q minus 1 divided by 2. So the only difference between these two equations is that we've got p and p squared. So when we get to this stage, we simply take the square root of both sides of the equation. The square root of 3q minus 1 divided by 2 will give us p. With this one, again, all we would have at this stage is the root of p is going to be equal to 3q minus 1 over 2. So exactly the same as we had before, but p would be equal to that quantity, and it's all of that squared. We need to square both the numerator and the denominator of that fraction, like so. Okay, let's look at the next ones. With the next ones, we've got two choices. When you solve an equation with fractions in, you can either see it as cross-multiplying or multiplying through by the lowest common multiple of the denominators. It's entirely up to you. If we have more than one fraction on each side, I prefer to multiply through by the lowest common multiple to clear the fractions. So what I'll do, I'll show you this one both ways, and the first technique is to cross-multiply. So when we cross-multiply, what we do is multiply the other side by the denominator of the fraction. So we multiply all of this side by 4 and all of this side by 2, which will give 4 bracket the root of p plus q will be equal to 2 bracket 5q minus 1. By all means, you could have written each of those terms as single fractions. So you could have written root of p over 2 plus q over 2 is equal to 5q over 4 minus a quarter. It does get messy though. At this stage, I would expand it out, and I'd write that this is 4 root p plus 4q is equal to 10q minus 2. We only want p on this side, so we subtract the 4q from both sides. I need to be careful when I say that. That will give me 6q minus 2. We need to divide both sides by the 4, so it gives me the root of p is 6q minus 2 divided by 4. If you want, you can even simplify that fraction, because each of these terms divides by 2. You don't have to. You might be expected to at some point. And now we simply square both sides. So 6q minus 2 over 4 all squared, which could be written, and I'll just put it here, p is equal to, dividing both of these now by 2, we would have had 3q minus 1 over 2 all squared. Exactly the same. So that's cross-multiplying. If you had multiplied both sides of the equation by the lowest common multiple, this would have taken out the fractions. Now, when I say taken out the fractions, it would have cancelled them off. So what we would do is multiply both sides of this equation now by the lowest common multiple. The lowest common multiple is the first number the two numbers go into. First number that both 2 and 4 go into is 4. So if we multiply both sides of this equation by 4, 4 over 2 is 2, so that leaves me 2, and then we're going to have the root of p plus q is equal to 4 over 4 is just 1, 5q minus 1. So 2 root p plus 2q is equal to 5q minus 1. 2 root p is equal to 3q minus 1 by subtracting the 2q from both sides. The root of p is equal to 3q minus 1 divided by 2, and then all we need to do is square both sides, and you can see it gives us this answer down here. So p is equal to the quantity 3q minus 1 over 2 all squared. So with the next one, it's not really an awful lot different to what we've just done. We could either cross-multiply, so multiply this side by 6 and this side by 2, or you could multiply by the lowest common multiple, the lowest common multiple being 6, and well, it's entirely up to you. If you'd cross-multiplied, you would have got this. That is going to be equal to that. Multiply it out as we did before, and then you would have dealt with that. If you'd multiply through by the lowest common multiple, multiplying both of these by 6, what we would have had is 3 root p plus q is equal to 5q minus 1. So that's the LCM, lowest common multiple 1. And you can see that that's going to give us simpler, a simplified answer, because at this stage you can see that both sides of this equation can still be divided by 2. With this one, again, cross-multiply or multiply through by the lowest common multiple. Now, the lowest common multiple of 3 and 4 is 12. So if we multiply both sides by 12, we'd have 4 bracket root of p plus q is equal to 3 bracket 5q minus 1, which gives you something very similar to what it looked like if you cross multiplied. But again, entirely up to you. I just think if you had, for example, let's say we had the root of p, if we had something really messy, over 3 plus, let's go for the root 2 root p minus 1 over 4 is going to be equal to q plus 1 over 6. I would simply be tempted now to find the lowest common multiple of 3, 4 and 6, which is 12, and simply multiply through the equation by 12. In doing so, what we'd have is 12 over 3, which gives me 4. Then we'd have 4 root p plus q. 12 over 4 gives me 3, so we'd have 3 lots of 2 root p minus 1. And then 12 over 6 gives me 2. So what we can see now is the fractions are cleared, and we can go ahead and deal with that by expanding out and collecting like terms, getting the p's on one side, or at least the root p to begin with, and the q's on the other. So, food for thought. Let's look at some more. What else have we got? Okay, the equation v squared equals u squared plus 2as is used in physics. So that's similar. It's one of the constant acceleration or Suvat equations, like we saw with v is equal to u plus at. We need to write down the subject of the equation. Well, the subject at the moment is v squared. V squared is equal to u squared plus 2as. So if we want to make v the subject, then what we've got is v squared is equal to u squared plus 2as. Then v is going to equal to plus or minus the square root of u squared plus 2as, as we need to do the inverse. The inverse of squaring, as we know, is square rooted. It's a plus or minus answer. Then it says, explain why there are two possible answers. Well, there's a plus or minus because it's a quadratic term. It's a v squared, so we can have two answers. And in context, velocity is like speed, but it also has a direction. So you might be travelling at 3 meters per second, and that's your speed. But you could have a velocity of 3 meters per second or negative 3 meters per second. So if you imagine that on a number line, positive 3 meters per second would be moving in the positive x direction, so moving to bigger positive numbers. Negative 3 as a velocity would be moving to the left, so it would be moving to bigger negative numbers, or, if you like, lower positive numbers. Okay, now we need to make u squared the subject of the equation. So what we have is v squared is equal to u squared plus 2as. So we need to isolate this u squared term. So all we need to do is do v squared minus 2as is equal to u squared. We now need to make a the subject. It says hence make u the subject. Well, we'll just take the square root of both sides of that. So u will be equal to plus or minus the square root of v squared minus 2as. Make a the subject. Well, v squared is equal to u squared plus 2as. So we need to isolate this term. So first thing we can do is subtract the u squared. So v squared minus u squared is equal to 2 multiplied by a multiplied by s. And I'm going to write this as 2s multiplied by a. Imagine this is just 3 times 4 times 2. So if this 2s, and that's not 25, it's 2s, is multiplied by a, to isolate the a and make a the subject, we need to do the inverse. And the inverse of multiplying by 2s is dividing by 2s, and that gives us a. So a is now the subject of that equation. And it says, state without any further work in what the equation would be if s was the subject. Well, we would simply swap the a and the s as we've seen. V squared minus u squared over 2a would be equal to s. Just consider this. 12 divided by 2 times by 3 is going to give us 2. Imagine, it's logic. So look at the other ways we can write this. This is just 12 divided by 6 is 2. 12 divided by 2 times by 2 is going to give us 3. That's exactly what I've done here. We simply use basic multiplication and division to do that. Okay, let's look at some others. Okay, make a the subject of the following equations. So here, no issue at all. This is a straightforward equation. If we've got now 3a plus b is equal to a plus 2b, all I need to do is get a's on one side, anything without an a on the other side. So if I subtract a from both sides, I've got 2a plus b is equal to 2b. I don't want this b on this side because I want the a's only on the left-hand side. So we subtract the b from both sides, and that leaves me 2a is equal to b. We only want 1a, so we simply write that a is equal to b divided by 2. Really straightforward, nothing crazy, no issues at all. With this one, we could multiply through by the lowest common multiple or simply cross multiply. I'm going to cross multiply. 3a plus b will be equal to 2 lots of a plus 2b. Expand the brackets. 3a plus b is equal to 2a plus 4b. We want a's over here, so we subtract the 2a from both sides. A plus b is equal to 4b. And then subtract the b from both sides. A is equal to 3b. Here, cross multiply or multiply through by 10. 10 is the lowest common multiple. Either way, you will get 5 lots of 3a plus b is equal to 2 lots of a plus 2b. Expanding the brackets, as we need to get the a's out, we want them on one side. 15a plus 5b is equal to 2a plus 4b. Take 2a from both sides. 13a plus 5b is equal to 4b. Subtract 5b from both sides. 13a is equal to negative 1 lot of b. And then at this stage, all we need to do is divide both sides by 13, so negative b over 13. Right, let's have a look at this one right here. This is no different to what we've just done. It's nothing crazy, exactly the same. Here, no different at all. Apart from, in fact, this one is slightly more interesting. 2 bracket a, b, let's just do that, minus c. So we're going to have a little bit, in fact, this is different and we need a slightly different skill for this. Minus c is equal to a minus b. So remember, all I'm trying to do on the left-hand side is get the a's, or I could get them on the right-hand side. It really doesn't matter. I'm going to get them on the left-hand side, though. I always prefer everything on the left-hand side, or at least as positive as possible. Let's go ahead and multiply this out. 2ab minus 2c is equal to a minus b. So that 2c I don't want because it doesn't have an a in. So everything on the left-hand side with an a, everything on the right-hand side without. 2ab minus a, by subtracting the a, is equal to 2c minus b by adding the 2c to both sides. At this stage, this is when the slightly more challenging technique comes in. We need to factor the a out. A is common to both of these expressions, so we factor that out, and that leaves us 2b minus 1 is equal to 2c minus b. So you might be looking at that thinking, well, I don't know what 2ab minus a is. All we do is isolate the a by factoring it and writing it now as a product. So a product is just a multiple, a times by 2b minus 1. Well, if a times by 2b minus 1 is 2c minus b, then a is equal to 2c minus b, all divided by 2b minus 1, and a is the subject. On this particular exam, these were always seen as the more challenging ones when you had to expand out, collect like terms, factor and divide through. Let's do the next one. So 2 bracket a minus c is equal to b plus ad. So we want a as a subject. 2a minus 2c is equal to b plus ad. Everything on the left with an a, everything on the right without an a. So 2a minus ad is equal to b plus 2c. Or you could write 2c plus b. Everything on the left-hand side has an a, everything on the right-hand side doesn't. We can isolate the a by factoring it out. Common factor of a, 2 minus d in the brackets, is equal to b plus 2c. And then dividing through both sides of the equation by the content of the bracket will give us a in terms of b, c and d. Let's do this one. So we've got c bracket a minus d is equal to b plus a multiplied by d. Expanding the brackets, I could write ca, I prefer it alphabetically, so I'm going to write ac minus cd is equal to b plus a multiplied by d. Everything on the left with an a, everything on the right without. ac minus ad is equal to b plus cd. At this stage, you could have subtracted b from both sides and subtracted ac from both sides. Doesn't matter, your answer will look very slightly different. The reason I do this is I try and keep as many terms positive as possible, but we'll look at it in a slightly different way. At this stage, I'll do it the other way now to show you. So over here, everything with an a is common. Take the a out, c minus d. That is the common factor, and that's b plus cd. So a is going to be equal to b plus cd divided by the content of this bracket, which is c minus d. Here's a reason I didn't go the other way. What we would have had is negative cd minus b is equal to ad minus ac. And I don't like this negative. So minus cd minus b will be equal to a, and then we would have had d minus c. So minus cd minus b divided by d minus c is equal to a. And this gives exactly the same values, or it's exactly the same as this. It's just essentially, if we multiply all through by -1, this will just change the signs over. And you might even see this factored. You might even see it written as negative cd plus b divided by d minus c. That is also an option. There's 3 different ways you can write that, and potentially more. I just prefer keeping things as stated, as positive as possible. So that was this one right here, wasn't it? This one here, no major issues with this. So let's go ahead. We've got d bracket a minus d. So d bracket a minus d. Remember, with all of these, we're expected to make a the subject, b minus 3ac. Expanding the brackets, a multiplied by d minus d multiplied by d, which is d squared, is equal to b minus 3ac. So AD plus 3AC is equal to B plus D squared, or D squared plus B. Everything on the left has an A, everything on the right doesn't. Taking A out, A is common, so it will be D plus 3C is equal to B plus D squared, and then A is equal to B plus D squared over D plus 3C, and we're sorted. We'll do the last one. I think, yeah, let's do this one. D bracket A minus D is equal to C bracket B minus 3AC. So expanding the bracket on the left, AD minus D squared is equal to BC minus 3AC squared on the right. I'll give you a second if you just want to think about that, because I did that relatively quickly. AD plus 3AC squared is equal to B times by C plus D squared. Everything on the left has an A, everything on the right doesn't. Factoring out the A, D plus 3C squared is equal to BC plus D squared. Dividing through by the content of the bracket, BC plus D squared divided by D plus 3C squared, and that is done. Right, we've been going nearly an hour, which is pretty crazy, but I think we'll do a couple more questions and then call it quits. Question 7, make x the subject of the following equations. So, first one's fine. All we need to do, again, is isolate on the left-hand side this x. So this is x divided by 3 minus 1 over z is going to be equal to y. So, x over 3 will be equal to z plus 1 over y. All I want over here is the x's. All I want over the other side is anything that doesn't have an x. If x divided by 3 is equal to y plus 1 over z, we can simply either divide both sides of the equation by a third or multiply by 3. X is equal to 3, the quantity y plus 1 over z, and that gives us x in terms of y and z. Okay, next one. 1 over x. So automatically this is not pretty. Doesn't matter at all. 1 over x is going to be equal to exactly the same y plus 1 over z by adding this 1 over z to both sides. Here comes my cheeky move that we saw earlier. 12 divided by 6 is equal to 2. 12 divided by 2 is equal to 6. Therefore, we can simply say that 1 divided by y plus 1 over z is equal to x, and x is now the subject. I've multiplied both sides by x, divided both sides by the quantity y plus 1 over z. At this stage, you might want to tidy this up by multiplying through this equation by z, and that would give z over y z plus 1 is equal to x. Entirely up to you. Right, okay, let's do the next one. We've got 1 over x minus 1 over z is equal to 1 over y. So 1 over x is equal to 1 over y plus 1 over z. Whatever you do here, do not go ahead and just turn these upside down. Don't do it. If you wanted the straightforward way, again, we can simply swap these over by writing this. That plus that is going to be equal to that. It's this again. If 1 divided by x is equal to this quantity, then 1 over this quantity is equal to x. You might be asked to write it a bit neater, and I think this is perfectly fine. But if we were, at this stage, 1 over x is equal to 1 over y plus 1 over z, what we could do is combine the fractions on the right-hand side. So 1 over x, combining these fractions, remember when we're adding or subtracting fractions we need a common denominator. So the common denominator is going to be yz, and that's going to give me z times y1, which is z, plus y times y1, which is y. And then at this stage, what we could do one way, and I'll do this 2 different ways, is write this. I think there's an even neater way of writing this, or we could go ahead and simply write that this is going to be x is equal to yz divided by z plus y. And it's more likely that you'll see that as the answer in a book. By multiplying up by the yz, multiplying up by the x, essentially cross multiplying. But again, lots of different options for you to look at with that one. Let's just finish with a question in context. Question 8 says the circumference of a circle is given as c is equal to 2 pi r. So this is now a formula. So rearranging equations, rearranging formulae, exactly the same. And the area is given as a is equal to pi r squared. In part A we need to express r in terms of c. Well, let's just write this out. C is equal to 2 pi r. What we need to do is write r in terms of c. So at the moment the circumference is expressed in terms of the radius. We want the radius in terms of the circumference. So all I need to do is bracket this off. 2 times pi times r. So c divided by 2 pi is equal to r. Remember, sometimes you'll see that c is equal to pi times the diameter. Diameter is twice the length of the radius. And this is what's lovely about maths. You often think, well, why do we have this number pi? Well, if we express d in terms of c, this would be c divided by pi is equal to d. Or we could say that c divided by d is equal to pi. And what does this give us? Well, this actually gives us pi. So what we can see is pi is a constant. Pi is just a number, and pi is, for any circle, the circumference divided by its diameter. And you can go ahead and try 1 trillion of them. You will always get the same number, 3.14159, blah, etc., blah. Take a circle, take its circumference, divide it by its diameter, and you'll always get pi. So that's the nice thing about where do things come from and what do they mean. Well, that's what pi is. It's the ratio of the circumference and the diameter. Okay, express r in terms of a. Well, a is equal to pi r squared. So what we need to do is write r, make r the subject. So we need to divide by pi. Pi is a number. Do not be scared of it. We now need to take the positive square root. The reason we take the positive square root is because now the radius is a length. So I always write final answers for positive square root. We can't have a negative length. So often in algebra, when we get a plus or minus answer, we can discard the negative answer because it doesn't work in context. Finally, express c in terms of a. Well, what we've got now are 2 expressions. If we look here, we've got r is equal to this, and r is equal to this. So if I want to express c in terms of a, then I can go ahead and simply now, as we got r is equal to and r is equal to, we can set these equal. So c divided by 2 pi is equal to the positive square root of a over pi. So if I want c in terms of a, we can write c is equal to 2 pi multiplied by the square root of a over pi. You could be cheeky and simplify this and write this now as 2 the root of a multiplied by pi. Because what we've got here is 2 times by pi times by a, and then divided by the square root of pi. Now the square root of pi If we divide pi by the square root of pi, we get the square root of pi. If you want to think about this as the rules of indices, what we've got here is that the square root is a half power, so when we're dividing we subtract the powers, and this is going to give us a pi to the power of half, which is a square root. So there we go. I'm getting tired, 1 hour 5 minutes, but hopefully that's given you an idea of how to rearrange equations. We've gone fairly deep into things, but hopefully you've got all the skills you need now to rearrange them.